Oh, it works now. Great. Hello. Thank you for coming to this tutorial on Patroni. My name is Alexey, my colleague is Alexander. We work in Zalando, we develop databases, and we also develop Patroni. We're very glad to have this opportunity to share our knowledge with you, and maybe after this masterclass, more people will use automatic failover with Patroni. We also want to tell you about additional opportunities that have not been covered in our presentations. On the screen you can see a slide for background instructions. If you have a laptop and you want to follow us, we will stop and say that you can execute this command on your laptop and get a result you need. In that case, you can download vagrant. By the address you can see on the slide, you can download vagrant file, conduct vagrant up and vagrant SSH, and you will get a virtual machine with ATCT and Postgres, as well as Patroni. We use this virtual machine to prepare slides. If you do not have a laptop or you do not want to follow us, it's no problem. We also have slides where you will see the results of all the actions that are to be done and the actions themselves, so you can just look at the slides. These slides will be available for you after our presentation, so you can always use them as a reference when you work with Patroni. First of all, I would like to get acquainted with you. Could you please tell me who has any experience of working with Patroni? Please raise your hands. Well, not everyone, but we have such people here. And whose main duty is to manage more than 10 Postgres clusters? We have such people here. We have even an intersection of these people. Patroni does not require you to have a lot of Postgres clusters. You can use it for one cluster, just to feel comfortable and to conduct failover. We have hundreds of clusters, and we trust Patroni every day to switch the role of master for the Postgres cluster we need, but you can use it for fewer clusters. Okay, let's start. In the beginning, I will tell you what we are going to do. At first, we will tell you about automatic failover, about a wrong way to do it, because actually there are many wrong ways to do it. If you were present at Alnander's presentation yesterday, he was speaking about modern high availability, then you are already aware of these wrong ways. We will tell you about the architecture of Patroni, because it's very important to understand the way the decision you are using works. After that, we will show you how to create clusters using Patroni. We will show you the details of changing a working cluster configuration without restarts, and if you need a restart, Patroni will help you understand when they are necessary. We will tell you about monitoring, about the opportunities that are built in Patroni for clusters monitoring. We will tell you about opportunities of expanding Patroni functions through user script that are executed in case of specific actions such as failover. These are callback scripts. We will also tell you about restreaming clients to master node. We will tell you about additional opportunities of Patroni, like restart or scheduled failover. We will speak about tags that are used for replications, modifications in Patroni. We will tell you about synchronous replication, and we will speak about various ways of creating replicas in Patroni and the way Patroni can solve such tasks as cloning existing cluster or conduct point-in-time recovery of an existing cluster. And in the end, we will speak about typical mistakes that we were faced with when supporting Patroni. We will tell you about the mistakes and the ways for rectifying them. Now I'm giving the floor to Alexander, and he will tell you about Patroni architecture and automatic failover. Hello. Well, we're not going to consider Patroni architecture. We will have a wide review of high availability solutions in order to make Postgres highly available. A solution in the form of warehouse has existed for a long time. This is so-called divided warehouse. This can be a network data warehouse when you has a section that is mounted on a server, and in case the master fails, this storage will be mounted on another server and Postgres will be launched there. Normally these solutions are quite expensive. That's why people prefer DLDB and Logical Volume Manager. To switch master, in this case they use Coruscant pacemaker. It's a very complicated system. And quite often people make mistakes in its settings. The problem of pacemakers is that they work most of the time and you forget the way it should be managed and set. And when the system fails, you realize that you have already forgotten everything and you do not know what to do. A logical replication or application that is based on triggers mean similar thing. Logical replication appeared in Postgres, in version 10 of Postgres about 6 months ago, but there is no big difference between trigger-based replication and logical replication. They have their own advantages and disadvantages. But the main disadvantage is that normally when using this logical replication, you replicate data alone. You do not replicate any service objects such as roles, users. You replicate separate bases or tables, so you cannot replicate a cluster. Fortunately, in 2009, Postgres 9.0 appeared, and in this system, physical streaming replication appeared. That makes it possible to replicate clusters one-on-one, and normally all high availability solutions are built on physical replication. Many people think that with the appearance of multi-master they will not have such a problem because they will have lots of nodes and every node will be able to accept data. Now it's possible to do it through BDR or Bucarda. But normally it is not something you want, because both BDR and Bucarda also replicate data alone. They do not replicate any service objects in the base, and in case of these solutions you will have to set conflict resolution because two nodes may be aimed at one and the same object, and it is not always clear how and in what sequence these changes are to be applied. Of course, you can set this strategy, but no strategy by default can be made that would suit everyone. That's why the majority of high availability decisions are built on streaming replication. And what problem do we have here? Streaming replication is not a complete high-availability solution because there is no built-in solution that would make it possible to transfer standby into the mode of a new master if something happened to the old master. Of course, this solution has a disadvantage because streaming replication can operate on the same major version, and the first thing that people try doing, well, we create a base that is a primary base, a master base. We create a standby base that will get data through streaming replication and write a script that will periodically send queries regarding master state, and if master is unavailable, standby becomes a new master. Who knows what can go wrong here? Well, we should be realistic, and network is not perfect. Sometimes it is not available, so nothing happened to the master. It is still working, it is servicing connections, but standby was somehow isolated. So what happens? We have two masters. This is a split-brain situation. That's why there is another approach. We will take decision on standby transformation into new master through a third server. And what can go wrong here? First of all, this service may disappear. We should be realistic. Sometimes hardware can fail, and in that case, we lose automatic failover. On the one hand, it's not critical, but on the other hand, what can happen when the node that takes decisions is not available? No one will comment Replica to switch. Another situation. Master and standby could find themselves in different segments of the network, and the node that takes decisions may be in the same segment where standby is, so node is not available although master is servicing connections, and the node decides to switch standby into a new master. And we get a split-brained situation again. And now I'm going to speak about contemporary and appropriate way of determining whether master and replica are alive. We can do it only if we have nodes that vote, an even number of nodes. We have 3 nodes here. If 2 of them agree that primary is not available, then these 2 nodes have majority of votes, 2 of 3. Why I do not recommend you to use even number? Well, it's quite okay, but In order to get majority from 4 nodes, 3 of them should agree. Of course, it's very important to kill the previous connection to the master. For these purposes, either stoneit is conducted. It means to shoot the other node in the head. Quorum makes it possible for us to solve difficult tasks of network partitioning. When one segment of network is not available, then other segments can take decisions, and the isolated segment, in this case, should stop the second master. And it's very good to have a watchdog. This is either a hardware or a software complex that makes it possible to restart the node if our service does not answer. For example, if something happened to Patroni, watchdog will not get periodic signals, pings, and it will restart the node. It's also a way to close the server because we should not leave Postgres broken. And now I will tell you about bot approach. It was made up by Compose team. Now, Compose is a subdivision. Well, it was bought by IBM. It's quite a big company. The idea is that with every Postgres on every node, we will have a special daemon that will manage our Postgres instance. If everything is okay and we have access to some distributed data storage, where we can renew log periodically, this node can work as a master. Or if we do not have a log, the node will work as a replica. And bot can be engaged in many things, but its main task is to monitor the fact that Postgres is working in master mode or in replica mode. And here is the way it happens. In the picture you can see node A, that is the current master, and it sends queries to etcd for leader key update. It does this by default once in 10 seconds. And leader key has PTL, that is time in seconds, after which the key will disappear. So, if suddenly something happens to our node and it does not update leader key, we will face a situation when the leader key disappears and 2 remaining nodes, or any other number of nodes, will get a notification that there is no leader and we should conduct a new election. How do they do it? Every node addresses all other nodes, including the previous master that had disappeared because maybe there were some temporary problems. Maybe the master is still alive. We have to make sure in it. And every node compares wall position with its own position. If the node is ahead of all other nodes or does not lag behind other nodes, all replicas, wall position was equal to 100. They start their race for leadership, so they send a query for the creation of new leader key. And what is the advantage of etcd? It makes it possible to conduct these things in an atomal way. So if one node created a key, then the second node, if it is prohibited to record the existing key, will not be able to create it. So node C won here. It managed to create the leader key. And node C becomes a new master. It conducts promote for Postgres, and node B becomes a new replica that will replicate not from node A that is not available, but from node C. And speaking about etcd, well, it is not the main topic of our masterclass, but Patroni depends on such distributed consistency stores as etcd, Concert, and Zookeeper. We can also use Kubernetes API. etcd is built on Raft algorithm, and for its functioning, we are to have more than 2 nodes. It's better to have 3 or 5 nodes. And following this link, you can play with etcd, with leader election, with the way etcd determines that what node is the leader node and what node is a replica node. And it's possible to resolve any network problems when one network becomes not available to other networks. It's network partitioning. I do not actually know how to say it in Russian. Patroni implements bot pattern. Patroni is written in Python, and it's we, Zalando, who is engaged in development, but we have many other developers. Mostly these are small patches, problem resolution, documentation sometimes, and one of cybertech employees helps us a lot. It's a very famous company engaged in Postgres consulting. They also use Patroni for their clients. So we're not the only user. And now it was an introduction. Now we're going to give you the main part. We're going to create our first Patroni cluster. Maybe for some of you it will not be the first cluster, but anyway, we will show you that it's quite easy to create a high-availability cluster. You will need only several comments for that. And the slide that you've seen from the very beginning. If you want to follow us, then in your computer you should install Vagrant, you should have a virtual machine, and you will have Vagrant SSH, and execute sudo Postgres commands. Could you please raise your hands if you want to follow us? That's great. If you have any difficulties, if you execute the comments that I do here, I hope that the comments that I do here will show you the result that you can see on the slide. But in case you get a different result, you can raise your hands and Sasha will come to you and try to help you solve this problem. I will not hurry, I will wait for each of you, and together we will try to get our first high-availability Patroni cluster because it's easy and I will show you how to do it. And one more question. Who has launched Vagrant up and has seen its finishing? That's great. Successful finishing? Okay. I will show you slides the way it should be, and I will show you my screen. If you do not see my screen, you can sit a bit closer or a bit further because it's possible to see it on these two displays as well. So Patroni launch is very easy. In our vagrant machine, etcd has already been launched. It's a local virtual machine. That's why only one instance of etcd was launched there on production clusters. You will launch 3 or more etcd instances because the idea of etcd is to store information on cluster state and leader key, and this is the system that should be constantly available. That's why please do not launch one etcd on production, because if it fails, you will have no high availability. Patroni will be in reading mode. Now, when we became Postgres user, we received 3 YAML files. Where did we take them from? We got them from GitHub, because Patroni is an open source project. That's why on GitHub you can find its source codes and YAML files. We did not make them up, we just took them the way they are, so you can repeat this on a local machine if you have Python, if you have all the dependencies on your local machine. Here is my machine. There are 2 Postgreses. I'm here already, and I launch Python. No, not Python, just Patroni, Postgres, YAML. Oh, interesting. We are to install Python etcd because in the latest versions you are to specify it. I'm sorry. This is the old version of virtual machine. Python etcd was not installed there, that's why we did not manage to connect. If anyone needs help, please raise your hands. Okay, let's try again. Yes, we need to enter Patroni catalog. That's great. So I launched the first Patroni node. The first node of Patroni saw that we did not have a cluster yet and initiated master node. It launched initdb. Initdb worked. Here we can see the export of initdb, and finally it showed us that we initiated a new cluster, and here is the log owner. So the node that we used for launching has a log. It has an ID that this is a leader, and it says so. I am Postgres 0. Everything's okay, I work as a master. Let's do similar thing with node 2. Let's launch Python, Patroni, Postgres 1, YML. What happened to the second node? The second node found etcd server. It realized that the cluster has already been created. It has a leader, and etcd has information about the cluster creation. That's why, instead of launching DB, it launched a Postgres utility that makes it possible for you to create replicas, and it created itself as a replica. So it created itself, and it tried to launch Postgres. It is waiting for Postgres launch. It may take some time. After that, it said that it cannot get WAL files from the master. Why can't it get WAL files? It said that it cannot get WAL files. Why? We made a replica, everything is okay, Patroni set it. The matter is that Patroni creates a replication slot for every replica. Who knows what slot replication is? For those who don't know, in Postgres, for streaming replication, there is an opportunity to save the changes that are to be transferred for a replica. So in a normal case, if we do not create a slot and your replica fails, then after some time, master will take all WAL files that were accumulated and aborted, and if replica is connects cluster, after that it will request WAL files that are not present there, and replication will not be possible. And you will have to reinitiate the replica. Spot replications were created in Postgres in order to solve this problem. So when you have a slot replication, this slot accumulates all changes and does not let Postgres fail these vault files. And when you switch the replica, it connects the slot and all files are transmitted. This approach also has disadvantages because if your replica failed and slot was created, no one processes these WAL files and they will be accumulated. That's why in Patroni there is an opportunity to turn off slot replication, but we recommend you to use them because in that case you will not have problems when you are to switch off replica for a short period and turn it on again.
So basically what happens there, he said it cannot just turn on the stream replication because the Patroni has not created a slot yet. So on master, Patroni looks at the list of replicas which are there and creates a slot for each of the replicas sometime later. So we have waited a bit. And now you see that these errors have stopped. These errors come from Postgres, not from Patroni. You can see we have connected to Postgres 1 slot. Postgres is one of the name of the replica, and it could not until a certain point in time when it finally created a slot, and then the replication started to work properly. So this message is displayed on the replica. It says the Postgres 0 has the master, and Postgres 1, I'm not master, I'm replica. I don't have, they do anything, then the promotion, for instance, because I followed the master who has a log. And then Patroni is going to show this on a regular scale. Quite often in our case. And both the master and the replica. So each time it's going to confirm that here it shows it is the master, and here it shows it is the replica. So who managed to bring it to the end? Please raise your hand. 2 people. What problems do the rest of you have? You don't have Python, sir. I'm very sorry. So let's do it this way. I will show you if you need it. So what you need is to go here, vagrant SSH, and tell this system pip install Python etcd. So this the command will install etcd. And then the commands which I made will finally meet with success. Patroni will find etcd and will do everything properly. Something wrong? Let's have a look. Because I've already installed it. What error does it come back with? Okay, let's try it as follows. So if I'm going to leave this slide, is the slide which shows this solution properly. Just if you could wait a second, I could help the people with their problems. It will take 3 to 5 minutes. I see that, and some of you have problems with installing Python etcd. So, not to lose time, let us solve these issues during the break between the two parts of the workshop, and then I and Sasha will try to help you. Now, let's move on. Yes. Did you manage to do it? If any DB does not work on some of your laptops, maybe you need to install. What was that? So basically, let's address them during the coffee break. Let's move on now. I have shown you how to create a Patroni cluster. So we have created this cluster. It works. It shows the master, the replica. So what I'm going to do next is we take the utility Patroni CTL. Patroni CTL is designed to control Patroni. It's for Patroni control. In this case, we're going to watch the state of the cluster. How are we going to do this? Well, we'll open yet another console. So I log in to Patroni. Right, Patroni CTL. I state the configuration of one of the nodes, and it will take the name of the cluster from this configuration. Alternatively, I can tell it the name of the cluster, and I will specify the list command. What do I get? I get this table. This table gives the name of the cluster, name of the node, either Postgres 0, Postgres 1, tells you the host and the role. And we see it's a living cluster, we have a leader, and we also see the state of the Postgres. Postgres is running on both nodes. The last column is whether we have replica, it can lag behind from master for some reason. Maybe because the replica is too old, or there's a big load on the network, or with the connection is not good quality. If there's a gap in time, the Patroni shows you this in the subparts column. We see there's no lagging now because there's no load on the cluster. So what I've shown you is not an automatic failover, isn't it? It's just how to utilize the cluster in terms of Patroni. Well, I want to show you how Patroni implements automatic failover. But there's a difference. Switchover and failover. Switchover should be switching between nodes in Russian. It's when you yourself decide to switch over the master to a different node, whereas failover or the emergency switching is when nothing depends on you. When your server is down, has it bent down, and you want Patroni to fail over to another computer. This is what we're going to show you. To this end, we will stop Patroni on the master server. All right. We will stop it using a special approach. We don't tell the system to Patroni because in this case it will stop Postgres too. So I do Control C, I put Patroni into the background regime, and Patroni is going to stop. So I've stopped it. This is my replica. What happens to the replica? So far, nothing. Why? Because so far Patroni has this leader regime. So far, etcd has the key of the leader yet. It could not. So far, he hasn't had an opportunity to go out of this pair. Some time will pass before it does it. With the default configuration, it takes up to 30 seconds. There's a special parameter which controls this. It's called time to release. I will tell you somewhat later. There's a certain ratio between various parameters in Patroni, but you can set it to 8 seconds or 10 seconds, maybe even less than that. Only you will need to strike a balance between how your network crashes or goes up and how reliable you want the failover to be. But I honestly wouldn't recommend to go anywhere beyond 30 seconds, really. So that's the latest message, 11:31. What happened at 11:33? What happened then is this warning in the docs. So Patroni said the request failed. So it couldn't get this because Patroni tried to see so that there was no lock in the network, to try the best to knock on the master's door. When the log is lost, Patroni knocks on every node's door, asking this particular node, "Are you master?" And two, if it's not a master, what's the wall position? To what extent, how close is this node to the master? So we had two nodes, and it tried asking the master whether it was available. Master came back with nothing because we stopped Patroni on master. And then, after this happened, Patroni decided to make promotion for itself. That is to become a leader. So, promoting itself to leader by acquiring session log. Промотировать себя на лидера. So it took about 2 seconds to get an answer from each node, but it starts spelling each node at the same time. So it waits for some time for us to wait, and then it promotes itself. No, not necessarily. Usually it's better to have a separate cluster. They are not too resource intensive. The mere requirement is not a big amount of memory or a large amount of processor, but it needs very fast disks. In this configuration, we have a daemon. We have only one etcd here. And it will show you how Patroni works. But this is something you can decide for yourself. You can have two nodes on which Postgres will run, and etcd will be on each of them, or you can have a third server which will be dedicated only to one node and etcd. Well, at the moment, like I said, we have one virtual machine there, with two etcd, with the two Patronis and two Postgres running on it, because it's mainly for the demonstration purpose. Now, if one etcd goes down, to a certain extent, this is a point of refusal, to a point of return, if you cannot restore it. But if your etcd works independent of Postgres, then these two servers will be doing their functions. So your task is that if one of the 10 servers goes down, you need to repair it quite quickly. So the question was, what will happen to etcd if network partitioning happens when one of the nodes is isolated? etcd also has a leader by itself, so it will choose a leader. If the isolated part of the network, if the leader was in the isolated part of the network, then the two remaining server will elect a new leader. And this new leader will be in one of the two remaining networks. No, not the second one. The second leader will start doing a reelection because it will see that the two other nodes are unavailable anymore. No, but no entry will be possible via the old leader. Okay, let's skip the further question. We can talk over the cup of coffee during the coffee break. Now, the node we have just left, the remaining Patroni, has promoted itself, and now it works as a leader and telling everybody I'm a leader. I have a bug of a Postgres 1. Yeah, we will do a very interesting thing now. You may remember that Postgres 0 we stopped our Patroni there on Postgres 0. And Postgres is now working as a master. We did that on purpose because in the real life, usually, some data may be not replicated. So we left this Postgres just to make a very small split brain. So it looks like this. We have a former replica that has promoted itself to a master. We have a former master which continued working as master because we switched to Patroni. Now we're going to take the former master and we'll write some data to it, and then we will see how Patroni is going to address this split brain. All I need to do now is create a table. So I'm creating this table, speed brain, split brain. Interestingly, in Postgres you can create tables without any columns at all. So I have created my table, but the most interesting thing is that I'm going to take the Patroni, which is stopped now, and I will tell it to continue its work. So we set Patroni to foreground start as the main process. And this is what we have received at the end. So Patroni told us that it unexpectedly saw it was a master, there was another master. So what it did is it emitted Postgres as quickly as possible. So it told Postgres to do immediate shutdown without any intercourse, any foreplay. So it did a panic shutdown, killed all the processes which were there, stopped the database, and they said, yes, okay, I did demit because I didn't have what I need. Well, and now Postgres was started. It was doing the so-called cache recovery because immediate shutdown is not a purely database installation. It prevents a rewind, PG rewind. PG rewind will refuse working with a cluster that didn't have a clean shutdown. This is why we have to start it in the so-called cache recovery mode. It does nothing, it simply runs it as a single user and then does PG rewind. Because all Patroni knows is that the old master was somewhat ahead of the new master when the promote happened. So we started in the cache recovery mode. So when it started, it checked its position wall segment, and it checked the master's wall segment, and it found a split because it was a replica, but it went ahead of master. So it decided to start the PG rewind. Who of you knows what PG rewind is? Perfect. So it's a utility in Postgres. I will tell you quite briefly, which helps the previous master to connect as a replica and to rewind all the changes that have not been recorded to the current master. So it rewinds back to the point where the split between the master and the replica happened, where the existing master did promote. And we will see it here. Yeah, it's PG rewind to Postgres 1, and PG rewind said yes, there was a split brain. The master and the replica had to split, and said that we did the rewind, and now we can see that the old master is connected as a replica. He says Postgres 1 is master and Postgres 0. So despite the split brain, which happened because we stopped Patroni, if we hadn't stopped Patroni, there wouldn't be any split brain. Despite the split brain, we still have been able to solve the situation automatically, which means that Patroni has been able to find what was there, to find the second master, to stop it quickly, then to launch it as a replica, to do PG reminder for it, and to include it into the cluster. So now we can have a look at the result of this utility work. And what we're going to see here now is a picture which looks very much similar to the previous one. Only we have now the leader of Postgres 1. Postgres 0 is also there. It works fine. It's a replica, and it is not lagging behind in any way. So we have shown you how the failover looks, and we have demonstrated to you that Patroni can solve this failover successfully. Yes, please. So what happened to the table which I inserted? The table is not there anymore. So if I'm going to go to the master now, I will not find this table because the data from the old master has been rewound. I will not be able to get this data. There was a split brain, so the data got lost. The task of the Patroni is not to allow any split brains. Unfortunately, we're living in the real world. And sometimes replication happens with a certain small delay, even in terms of milliseconds. So a certain number of transactions can get lost in case of an accident. And so to avoid losses, you need to do synchronous, simultaneous replication. Patroni supports it. We'll get a bit later to it. But mostly, people use asynchronous replication, but synchronous replication kills your performance. Okay, the next thing I would like to tell you is about the contents of the etcd. It's the content that keeps information about our cluster. So I can show you what we store inside etcd. It can also be Kubernetes, Zookeeper, or any other structure. So etcd there's a key of the value. We have keys. These keys have values. You will see right away that we have this key, and for the members we have keys for each of the Postgres 0, Postgres 1. We have initialized key, which says the cluster has been initialized. The cluster identifier is stored inside and helps to get connected only to those who are part of this cluster. If you connect a node which is part of a different cluster, it will not be able to connect, because the initialized key has all the information about the cluster participants and the key connected to the cluster configuration. Let me show it on the slide, please, because they demonstrate this slightly better. You'll see the same result here, and then I'll look at what the members Postgres 1 node stores, and it's JSON, which stores a number of very significant parameters. For instance, it stores the URL, which you can use to connect to this Postgres, to the Postgres database, that is. It stores the URL API. Patroni can use it to ask another Patroni node when it does promotion. It can ask whether the other one is the master or not. It contains the information about the database state, because Patroni can be launched but not the database, for instance. Maybe it's in the very beginning, etc. We store the role and the current position for this type. So to what extent does it restore or store what segments? We also have a number of other keys. History, which shows if you know what timeline history is, it's the history of promotions of that cluster, and the history of how the cluster was built from Replica to master over several times. So this contains the history at the time when it was promoted. So you can use this key to find out, for instance, when it's happened, when the latest failover happened. The next thing I would like to show you. So we have a cluster, it works. I want to show you how you can dynamically change your Postgres configuration. Why is this important? Why do you need it? Why do we need it? Because you have a cluster, you have a number of nodes there. Clearly, you can go to each of the nodes and change PostgreSQL conf or to system, but these changes will only be applied to one node, whereas in a real situation, when you launch a cluster with a master several replicas, you will want very badly the configuration of these nodes to be similar, identical, because otherwise each of your replicas can become a master. You don't want your master to have the shared buffers and max connection parameters to differ from one node to another. So all I want to show you now is how to edit the parameter which is maintenance work memory, which hints the Postgres planner how much memory is available for queries. But this is for vacuum and for creating indexes. So I'm going to take Patroni KTL for this purpose. I'll do it like this. I'll show the configuration. So I'll show edit config, and we'll show the cluster name. All right. You need to select your favorite editor. You can specify vim inside it or num. So this is the num command, and this is the result. So all I want to do now is to insert this parameter for maintenance. Postgres parameters, and I insert it there. Maintenance work mem 128 megabytes. All right. Then I save it, I exit the editor, and Patroni highlights it. It highlights these changes, asks whether I would like to apply these changes. I say yes, I want to apply the changes. And then let us see what happened to our masters. Let's look at the leader, for instance. So the leader says, I received a sig hop. It's the signal which tells Postgres to boot the configuration. So and now it says that the parameters are 128 megabit. I'll go to my replica and I will see the same. It says I received sig hop, and the parameters are 128 megabytes too. So we have done the same action on one node, and the result of this node has been applied to the entire cluster. Patroni did reload for you. All you need to do now is to change the configuration in just one place, and Patroni will do the rest, the remaining configuration activities for you. Patroni control can be started from your notebook. You don't need to go to any other computer. Now let's do a more interesting thing. Maintenance work can be changed without rebooting the cluster. Now let us look at what we get if we need change a parameter that requires cluster rebooting. Let's change, for instance, the max connections parameter. Who knows what max connections is in charge of? It's the highest number of connections which your Postgres cluster can receive. If you send more customers than the max connection value is, then your customers will receive the message that it cannot. And who knows that max connections cannot be installed in numbers? The number of max connections on the replica cannot be lower than on the master. And who knows why? No, not only. Well, is also written there. So basically, max connections is now one-on-one, and we will see what happens.
is the same conclusion. Max connection was changed. It is 101. Apply changes, apply the result, and let's look at the master. Will it show something or not? So it continues working. It says, I'm Postgres 1, and it does not show anything, as if nothing happened. Why? Because in order to change this parameter, we need to restart Postgres. And Patroni will not restart your cluster instead of you, because if you restart the master, then clients who connect the master will be disconnected and developers will call you and ask what you are doing in the middle of production and why do you need to do it. That's why this solution is for the user. For you, I mean. How can we learn that we need to restart cluster? We can ask Patroni itself. How can we do it? We can use REST API. Patroni has REST API that makes it possible for you to get a lot of information about the cluster, in particular the information that is present in etcd. So now we will execute this command. For example, 008. And what can we see here? We see that this is a replica. Yes, this is a replica, but it's not actually important. Apart from being a replica, we can see that we have pending restart here. It means that we need to restart it. We did not have this flag before, but now we have it. Its value is true. It means that for all the changes to become valid, we are to restart the cluster. If we go to master, then we will see similar thing. All nodes are waiting for the cluster restart. You can see it here as well. On both nodes we have this flag. Now we need to restart this cluster. In Patroni we can launch control list to see this thing. Parameters at first. Excuse me, could you please repeat your question? PostgreSQL 0 is a replica. That's true. Look at the ports. We made 2 queries to REST API. One port was 8008, the other one was 8009. 8008 is PostgreSQL 0 and 8009 is PostgreSQL 1. They use different ports. The master is on PostgreSQL 1 and we can see port 9. This is the master. Patroni CTL. It shows that both nodes are to be restarted. What can we do now? We can restart KTL Patroni. We can restart Patroni through Patroni CTL restart. And we need to specify the node that is to be restarted. So I want to restart PostgreSQL 1, that is the master. PostgreSQL restart. And cluster name. Here we have 2 clusters. It asks what node I want to restart. Now it requests your confirmation. I say that I want to restart all clusters, Postgres 1 and Postgres 2. In a production situation, I can restart replicas and after that restart the master, or I can restart the master. Restart has various options. I'm not going to tell you about them. So we restarted the replica, we restarted the master. I'm sorry. And master has not lost its key, so it remained the master. And the replica is a replica. Now let's check whether we've managed to change mask connections or not. We can connect any of these nodes and insert the command show mask connections. 101 and 101 on the other node as well. So we changed mask connections through Patroni, we restarted the whole cluster and the changes were applied. If we did it manually, we would have been to be very careful because mask connections on replica should be no less than mask connections on master. And if we, in the very beginning, increased mask connections on master and replica would remain unchanged, then replica would not be able to replicate the data from the master if we did everything manually. In case we use Patroni, we do not have to think about it. Patroni will do everything itself. So if replica understands that mask connections on master was increased, it will stop. Patroni will see that Postgres does not work and launch it with new mask connections. Yes. The matter is that restart requires to specify the name of the cluster and one node, for example, the name of one node, so you can select what node you want to restart. Yes, Batman is cluster name. If no nodes are specified, it will make restart for all nodes in the cluster, but you can specify some specific node. What parameters apart from mask connections are written in wall? What parameters? Well, we will speak about it a bit later. There is a number of parameters that are to be identical on all nodes. We will speak about it later. Now, so Patroni worked, it's okay. Now I want to show you an emergency situation when something goes wrong. For this purpose, I will stop at Patroni configuration. So we changed Postgres configuration now, but Patroni also has configuration that is written in YMO, and we had a question: how fast can replica determine that master is not there and make promotion? After that, this behavior is regulated by time to leave parameter TTL, that is time of life of leader key in etcd or in another system, and there is a dependence between TTL parameter and some other parameters. How does Patroni work? Patroni has an event loop that is the cycle of events processing. When it looks at its role, it checks some actions that it is to do, for example, to do restart, to do failover or something else, and after that, if no actions are necessary, it falls asleep, and after that, it wakes up. So the time of its sleep is loop wait parameter. How long it waits before the new operation of cycle starts? What happens if this parameter is higher than TTL? Patroni will sleep. During its sleep, it will lose the key, and promotion of another node will happen. And with this node, situation will be similar. This node will sleep, it will lose its key, its leader key, and promotion will happen again. No, there will be no promotion. Why? I will tell you about it. So we have different opinions. That's why there is a dependency, that TTL should be more than loop wait. But here there is another component, because when Patroni does not see etcd, it tries to connect it several times in order to make sure that it is not present. And this time of connection is regulated by retry timeout parameter. So the formula is as follows. Time to leave of leader key should be higher than loop wait plus two values of retry timeout. And on the scheme we can see that there is loop wait, retry timeout, and this big thing, this big bracket, is the time of leader key expiry, that is TTL. We will try to violate this dependency. Loop wait will be very small and TTL will be very big. Wrong slide. Why? So TTL is big, loop wait is small. Here is the slide that we need. Loop wait is 10 seconds and TTL is 5 seconds. So leader key will expire when Patroni will be sleeping. Patroni CTL edit config and TTL is 5 and loop wait is 10. We can leave retry timeout the way it is and we will see what happens. So we applied these changes and at once we can see that the support that is present in Patroni said that an error had occurred. Because in this case, if we started Watchdog, it would have killed this cluster because we do not have a leader key. What else can we see here? We can see that our leader lost its leader key and received it again. So Postgres works as a master. It writes acquired session, work as a leader. So what happened? While our Patroni was sleeping, leader key expired, Patroni was still the master. After that, it saw that it is a master and it does not have a leader key, so it needs to receive it. It received the leader key, fell asleep, the leader key expired because the sleeping time was longer than the key expiration time, and this behavior occurs all the time. So it takes leader key and loses it. It's more interesting to check what's going on the replica. It's a chaos because the replica, well, there is no more leader key and replica tries to elect itself as a new leader. And it gets a response from the current leader. So when it tries to elect itself as the current leader, it sends a query to the leader, and the leader says that it is alive and it has a master role. That's why the replica says that it cannot do promotion and it should follow the leader. In this case, in etcd, nothing is recorded. It is empty. That's why it is not following anyone. It says following a different leader. But we do not have etcd key, and that's why it is in reading mode, so it is not replicating from anywhere. And this situation is repeated. We have a master that receives its key, and there is a replica that just stopped and does not do anything. But we should not do it. Yes, we should not do it. That's why we will change configuration and make sure that everything works. So TTL, yes? Well, yes, we're thinking about it, but initially the idea was that it is you who is responsible for the things you are doing. TTL is 30. The matter is that these parameters can be changed very easily. And what can you do if you inserted some values that do not satisfy this condition? It's not clear. So we cannot stop the cluster. It's not the best solution. I think that you agree with it. And so You are saying that when we edit these parameters through the editor, actually they can be changed through command line as well. Some warnings should be showed. That's a good idea. We will have an issue and implement it. Thank you. You can change configuration through REST API as well through your client that will not have any verifications. You should always remember that you can change these parameters, TTL and loop fade parameters, so that nothing will work. So I changed configuration, and you can see that the leader stopped receiving its keys. So its operation is stable now, and the replica connected the leader and started normal replication. So that's the way I showed you that it is important that TTL should be higher than loop weight. The conclusion is as follows. If you want to define that your master is gone and you want to do it quickly, you are to decrease TTL. But when you decrease TTL, you should also monitor the observance of this ratio. So loop weight should be decreased as well, otherwise you will have this problem. And retry timeout should also be decreased. But remember that sometimes network may lag. And if during retry timeout you do not manage to conduct some action in etcd, then Patroni will demote to the current master. In data center, where our servers work, we increased TTL up to 60 seconds because once we had a problem when switches restarted and during 30 seconds there was no connection. And when master goes here and there, it's not the best situation. Speaking about configuration, I would like to show you the configuration of Patroni itself. In this case, let's have a look at this configuration. It's a typical configuration. You can see it on the screen. And in this configuration, there is bootstrap section. In this bootstrap section, we can see these parameters TTL and loop weight that we mentioned here, and retry, timeout, and some other parameters, including Postgres parameters. Why do we need this bootstrap section? When you initialize an absolutely new cluster in etcd, then the parameters from this bootstrap section are recorded into etcd, and after that they are applied on other nodes of this cluster, in particular this TTL, this loop fade, are recorded initially, and after that the new node gets these parameters from etcd and continues working with them. In particular, we have PostgreSQL parameters that show that we want to use PG rewind. This is Patroni parameter. We can also specify Postgres parameter. In this case, we do not have anything here. We can specify any parameter and it will be applied on all the nodes of the cluster when the cluster is launched. But if after the cluster was created you changed the bootstrap section and restarted Patroni, then nothing will happen. All further operation with this configuration should be conducted through Patroni control, so you should change it in OTCD. Patroni control provides a convenient interface for it. So when the cluster was created, roughly speaking, when the first node of this cluster, when information was created in etcd and the first node was initiated from this moment, whatever you change in this bootstrap section, these changes will not be included in serial because these parameters are recorded during initial cluster creation, and after that they are ignored. What can we do here? How can we change parameters in Postgres? Well, we have several opportunities for it, several ways to do it. One way is to change them in Patroni via mail. We have Bootstrap section, but if we go below, we will find PostgreSQL section. And in this section, the parameters that we specify will be local for this cluster. So through Patroni parameters, we can input some parameters on this node of the cluster, and they will not be applied to other nodes of the cluster. For example, if our cluster nodes are not equal in terms of hardware configuration, on one node we have 16 gigabytes of memory and on the other one we have 4 gigabytes, then we can insert 4 and 1 gigabytes of shared buffers. So we will have a balance. One of the ways of Patroni configuration change is local configuration. There are other ways too. We can change this configuration in etcd. In etcd we have config key. We can look at it now. etcd cdl. Alert service button. Our configuration is combined from various sources. First of all, we look at things that are stored in etcd. After that, we check Patroni YML, that is configuration file in this node. We can redefine some parameters if you want it. In production, we normally do not do it because all servers are almost similar. And the third option is to change it in Postgres configuration file. Option 4 is Ultra System or something else. We're going to speak about it later. I wanted to show you what we have in etcd configuration. Here we have configuration that was initiated at the moment of Bootstrap when the cluster was created. Here it is: retry timeout loop wait and Postgres parameters. So in etcd we can record something into Postgres parameters, and things that are recorded there will be applied by Patroni on the nodes of the cluster when we conduct Patroni reload. And Patroni control shows this configuration when we edit it. But the difference is that it is stored in JSON, and Patroni control uses YML that is readable and that is written by a person, because editing JSON manually is quite difficult. Unfortunately, the speaker is off the mic. Look here, first of all, it takes it from etcd. If the same parameter is indicated in Patroni YML, it will redefine the things written in etcd. Workman in etcd was 16 megabytes, in Patroni YML it is 12 megabytes, so Patroni YAML will be a priority. How does it work? Patroni will generate a Postgres configuration file where 12 megabytes will be recorded. After that, you will be able to use Ultra System. But it's not obligatory. So Patroni YML has a priority over etcd. For example, PostgreSQL that writes Patroni is written by Patroni for the initiated cluster. This is just PostgreSQL. I will show you the command. I want to see the components of this file, and the first two lines say that this file should not be edited manually because it was created by Patroni, and the next line is include postgresql.base.com. We can look at this PostgreSQL, so you can edit this base file, or you can tell Patroni configuration to use not the base file but some other file, so the file that you can deploy from Git, from SLN, or from other sources, and that can be managed by you. Patroni took original PostgreSQL and renamed it into postgresql.base.conf. This is the initial Postgres file. And after that, It created its own PostgreSQL where it records the parameters that it gets from etcd and other sources and included it here. What do we have? Thanks to it, we have an opportunity to edit configuration through auto-system command. These parameters will be applied and written in PostgreSQL, and they will be used. But if you conduct auto-system on some node, then the parameters that you changed will be applied on one node only. If you want to change the parameters everywhere, globally, in the whole cluster, then you should use Patroni CTL edit config the way that I showed you at the example of maintenance work MAME or shade buffers. In this case, they will be applied on all the nodes of the cluster. Here you can see the sequence that we mentioned. At first, we take parameters from config key. The parameters can be redefined in Patroni YML. If they are redefined in Patroni YML for this specific node, then they will be a priority if one parameter is specified in there and in configure. And there are auto-system parameters that are even a better priority for this node. But if you change something through auto-system that requires cluster restart, for example, mass connections parameter, then Patroni will not tell you about it through pending restart. So through auto-system, it's not possible to change mass connections. Okay, it's a bad example. Shade buffers. There is a list of parameters. These are parameters that are... So parameters on master and replica are dependable. Values on replica should be no less than values on the master. This is about mass connections, mass transactions, flow level, because it regulates the way wall is created on master. So if you have minimum there will be no replica because it will not be able to play them. And Patroni will not allow you to insert minimum. It should be either replica or logical. So what happens with Patroni? It launches Postgres and transfer this parameter to command line. That's why you will not be able to redefine them locally for this specific cluster, because it will be rewritten by Patroni. You should use Patroni cd edit config globally for the whole cluster. And this is something you want because it will make it possible for you to avoid mistakes and avoid a case when replica cannot start because this parameter has an incorrect value. And now we can have a break. We have a 15-minute coffee break. If you have any questions, please don't be shy. If you did not manage to follow us, we can help you and help you rectify the mistakes that you made.
Да, здравствуйте еще раз. Мы продолжаем. Кофе-брейк затянулся немного.
Hello again. We're continuing our work. The coffee break has lasted a bit longer than we expected. Now let's talk about the Patroni mainly, and about a REST API, how you can use it, and what it is there for. But from the very beginning of the Patroni project, it included 2 or 3 endpoints into REST API. One of them is master, or just slash. It understands get requested, but only options, which is not so important. What do we need it for? The master will return OK status 200 only if this concrete node works as master. PostgreSQL does not work in recoveries, and we have a leader key, a replica. It will return the 200 status only if this node works as a replica, if it's not excluded from the read-only load balancing, and if Postgres is functional. If Postgres is starting or is down or something else, then the replica will not return 200. It will return 503. Same with the master. If the node works as a master, then this endpoint / master will return 503. So there's also Patroni. Patroni returns the same reply as the master or replica do. They also return the JSON document in addition to the status, which will list the log position, Postgres status of the tags set up for this particular node, and some other additional information. For instance, if that particular node requires a restart or similar things. But the difference is that the Patroni always returns the 200 status. There's another endpoint. It's for changing and reviewing configurations. Well, we don't need it that much because everything is done via Patroni control now. But previously it was one of the means to do the global configuration. But Patroni cannot do switchover or failover. As we all know, switchover is a regular operation. There was a master. It was fully functional, but then for some reason we decided that the master should be now on a different server. Because, for instance, the old server needs maintenance or something, or we need to replace the hard disk, or one of the power modules is out of order. Patroni also can restart Postgres using REST API. We have the restart 8.4 for this. Also, Patroni can reinitialize clusters. So there can be a case when you cannot either restart your replica or rewind it, and it's lagging far behind your master. Maybe you lost some files or something, and then the only option would be to do full reinitialize, to sub Postgres, to delete the data directory, and to take the backup. In this case, most of the endpoints are used by Patroni control, and you don't need to touch them at all. So this is how the master does it. This is how the reply from Patroni endpoint to master looks like. So this is a JSON document. It shows us the system identifier. It is only generated when we create a new cluster. It tells us what the cluster this is, what the name is, what the pathman is, what in Postgres was started. We also see the replication status in this master. It says it's working as a master, shows us the integer, and tells us the Postgres version as well. In this case is 10.0. But you can also monitor your Postgres, and you will know that your Postgres is the latest version. This is 10.0, so we have been we know that there is a 10.1 for some 3 months now, and there'll be 10.2 as of tomorrow. It looks more or less the same in Replica, and it says this: it's a replica, it's working, it's running, timeline 2. Xlog looks slightly different too, because the replica has got information about how many, what position of the Xlog was received from master, how much has been applied, the latest timestamp. In this case, it's null. Does any of you know why the timestamp is null? Because we haven't had any activities. So, if there were no transaction on the master, then nothing would be. You would not know what the timestamp of the latest transaction was. So a reply timestamp has grown bigger for some reason, 300 bytes bigger. I wonder why. How can this happen? I'm sorry I cannot hear what the gentleman in the audience is saying. No. Well, the thing is that the two functions which return these positions are not transactional functions. The thing is, the query is formatted, is built in such a way that the received timestamp is requested before the reply timestamp. Well, we'll clearly fix it whatever we can, and we'll change the place. So you can use this endpoint to monitor the state of the Postgres, to state the status of Patroni. You can use it also to redirect the client connections to master, or to do some balancing between replicas. HA proxy can send these active queries about the status. HA proxy sends them on a regular case to all the nodes described in their configurations, asking them to tell whether it is working as a master. Clearly, only a master will come back with the 200, and replicas will come back with 503. And it's the other way around with replicas. And the HA proxy can send, then you can send the client requests to master only to the masters. How else can you redirect client connects? If you're working inside one data center, or if you can assign IP addresses between different data centers, but within one realm, or you didn't need to change the DNS. Well, Patroni can execute a file, a shell script usually. Patroni can use this file in case of a certain event. For instance, when it's starting Postgres, then it will execute a script which described on start, or once the Postgres is stopped, it will execute the script that it is described in the on stop. On reload, on restart, it's basically the same. Or on route change. This is a bit more tricky. Let's say we had a replica that became a master. So we did PGControl promote, and right after that, Patroni did a script that described an on-roll change. And you can assign a new virtual IP. Since the cluster topology can change, we can move it from one machine to another, and the IP can change as well. So it's not an easy task to maintain the HA proxy configuration. So we don't want to change things in HA proxy, like delete the old new node, add a new node. So to this end, there's a special utility. The author is Kelson Hightower. This bloke works for Kubernetes. This utility takes the information from the ATCT, from or takes some variables and makes a configuration file using a template. So this utility has well, the first thing we'll see there is a setting file, which shows you whenever something changes in ATCD, you take this file, and if the new configuration file is changed, so this config can check it, can execute command which will check the new file for correctness. And if the check was was successful, it can save the new file and restart it or reread the new configuration of HA proxy. And we will see how this template looks. So this is a template for HA proxy. We describe max connections, which describe the timeouts, and the two servers. Server 1, which is going to redirect the traffic to master, the other one that is going to balance the traffic between the replicas. But most importantly, we must apply this option on marked down shutdown sessions. This means that if the nodes that used to be master previously started to come back with 503 or started was lost at all, the HA proxy will simply cut off all these connections. It will not send our requests from the client to the server, which used to be a master but now stopped to exist. Because there can be scaled Postgres still works, still executes certain transactions. So we must prevent this. And HA proxy helps to solve this issue. So this tricky structure here, it is not so easy to read. It was even more difficult to write. So it generates the list of nodes where HA proxy will do this health checks and balancing. Or we have another option. We can basically adapt the same approach to conf.d, so it will generate config for PG Bouncer. This may be even better because PG Bouncer knows how to put our connection on hold. And if it so happens that the master is moved to a different node because the payload occurred, then the client will not probably even see it because the PG Bouncer will help to resolve the situation. Starting from Postgres version 10, we will be able to identify a number of hosts. We will ask for a read-or-write regime, and libq will try and connect us to all the hosts. If it's a master, then we will stop at this. Or you can specify read-only or something similar. Now let's have a closer look at callback. So it's an example of the configuration that is used in our classical data center. We have a callback script which either adds this service IP, the virtual IP, or removes it in certain cases. If we're starting as a master, or in case our node was promoted to a master, then we have to add it. Have to add the service IP, a virtual IP. In all other cases, we'll have to remove it from that particular node. So this script is executed on one node only. The other node, if it has it, it will execute it irrespectively. So the script as a parameter will get a name to start with. Then it will get a role, which this particular node has. If this node is a master now, then the script will look as on-rel change master, and then the name of the cluster. Furthermore, it is important to bear in mind that these callbacks are asynchronous to all other actions in the cluster. So it can happen that the master keeps hopping from one place to another, and the callback will finally stop on a node where it was a callback on a node where it was launched will stop after it is stopped on a different node. So as a result, we can find ourselves in an unpleasant situation where the virtual IP was assigned to a wrong node. So we should be quite careful about it. When we have this issue, you can read about it in greater detail. But well, basically, so far it works. Haven't had any major issues. Also, quite often you get a situation where you need to be able to manage individual nodes. What can we do if there's a node in the remote data center and we don't want it to become a master because of this selection? We can use the tag mechanism. These tags are specified in the Patroni configuration. You can only specify them in the configuration. Even if you specify them globally in the etct, then they will not have any meaning on the nodes. So you should only write them in the configuration file. If you want to prevent node from becoming a master, then you can set this tag no failover true. No failover. Failover. Oh, we have another tag, no load balance. If we do read only with HE proxy, then when a node still is working as a replica, it will still come back with the 503 status. If the tag is true. There's another interesting tag, claim from. It tells you that the node allows to take backup from it. PGBase backup can do backup not only from master but from any replica. If you're creating new nodes, then you usually don't want to overload the master with useless load. For instance, you want to copy 1 terabyte, but the master has got a lot to do. So, if any of the existing nodes has this claim from tag, then Patroni will simply take basic backup from that node. If there are multiple nodes like this, then it will pick one of them at a random basis and use it. You can also control the asynchronous replication at this level for each of the nodes. For instance, a node may be located in a remote data center, the ping is too long, and we don't want this node to become synchronous at all, even if it's just the only node remaining there. In this case, we can tell it to become no sync. And last but not least, Patroni offers an opportunity to make cascade solutions. You can replicate, not directly from the master, but from an existing node. When can this be useful? Let's say you have 2 or 3 data centers, and one of them is quite remote. Then you set up one of the nodes in that data center to replicate from the master, and all the other nodes will replicate from that particular node. So you will have traffic go from one data center to another data center just once, which is quite useful when the channel is too narrow or the traffic is too expensive. But it is important here that all the previous tags were Boolean type, but replicate from tells you from what particular node we want to replicate the data. Why can't you make it the other way around? Why can't you make it Boolean either? Oh, because Patroni creates replication slots, and a node cannot create a replication slots for any other node unless it knows that you want to replicate from it. The master creates slots for all the nodes that want to replicate from the master, whereas a node that does a cascade replication will only create slots for the nodes that want to replicate from itself. What do you need the replication slot for? Do you know it? A replication slot is there to avoid the deletion of all file segments that for some reason have not been replicated. While Postgres was unavailable or was too late on one particular slot. And like I said, you can only configure tags inside Patroni on the configured file, and you don't need to write it into etcd. Or you can play with cascade replication. You will have Postgres 2 for this, YML files. And if memory serves, it has to replicate from Postgres 1. So Postgres 1 will create a replication slot, and a replication Postgres 2 will replicate from it. What's the difference between switchover and failover? And can a failover be always automatic? Well, a switchover is part of the maintenance work, of the plan maintenance. You simply switch the master from one node to another node. And a failover is a case when something crashes. But there can be issues with failovers. Patroni, for instance, controls whether you can use this particular replica to become a new master. And there can be cases when the replica is lagging far behind. And the master was writing its latest position to etcd on a regular scale. It's xlog. This is a parameter which you can set. I think it's 0 by default, or maybe 10 megabytes. In any case, it is open for settings, depending on what you need. So if nodes see that the lag is longer than these 10 megabytes, then the node decides it cannot become a new master anymore. Clearly, the stars in the heavens can meet in such a way that all the nodes start lagging too far behind. In this case, you will use the manual failover. You can select a particular node which is the closest to the master manually, and tell the system you become the new master. A switchover can happen at any given point in time, or you can tell Patroni to make it after a certain period of time. But you can only make a switchover if there's a master and if the master is functional. But most importantly, Patroni will take care about identifying whether any other nodes can become a new master. So before shutting Postgres down, Patroni will connect to the remaining nodes to see if there's a good candidate for this. If there's no good candidate, then it will simply refuse to do the switchover. So it is foolproof in this respect. It does not shoot itself into the leg. So now let us try to do a switchover. One more thing I wanted to ask. We have two options. We can either tell you in every detail and show everything on screen, or we can leave some more time for your questions. Who is for leaving more time for Q&A? And who would like to watch these commands as I'm typing them in? Nobody? One person. Perfect. Two people. Perfect. So let's do it as follows. Why don't we skip some of the commands? I want to show you the switchover. I will show synchronous replication in the interactive mode, and the rest I will show you on screen because the slides are very detailed. I'm sorry I cannot hear the questions from the audience. So these commands are written on slides. We're using the same commands, and the slides will be available for download. You will have an opportunity to look at them. I'm very sorry the background box did not work now, but you will be able to see it. You will be able to repeat it after the workshop. Okay, now let's have a look at the switchover. Well, basically what I'm going to do now, I'm going to launch this same command, Patroni city switch over, and I will specify the name of the cluster, Batman. If memory serves me right, we still have to specify the configuration parameters. Because Patroni CTL needs to find this city. Alright, so Patroni is asking master, Postgres 1. I press enter, so I agree. It offers a candidate. I can specify a concrete candidate, or I can tell it I don't care, and then it will switch over to a replica, to any replica which will meet the conditions for switchover. It should be quite close to the master, and Postgres will be switchover guarantees no loss of data. So one of the replicas, all the replicas that replicate from the master will receive all the data from the previous master guaranteed. Now the most interesting part. We can switch over according to a certain schedule. So we can tell the system to switch over a bit later. First, you need to update all the replicas to the latest Postgres version. And then let's say it's 4 a.m., it will do the switchover, so that you don't have to stand up and to do this manually. So Patroni can do it for you. We did it many times on Amazon, and we're very happy that we have this opportunity because it saves you. It helps you to sleep at night rather than maintain your clusters. You know, switching over 150 clusters over one night is not the funniest thing you can do. Patroni CSAL. It shows me the latest confirmation. Do you really want to do this? I say yes. So this is the replica, Postgres 0, and this is the master, Postgres 1. I tell the system yes. And let's see what happens. Patroni list Batman. Most probably, but yes, the leader has already changed. So when I tell the system switch over, it says successfully failed over to Postgres 0. You can see right away that Postgres 0 is a leader now, and the previous master was stopped. We stopped it and we changed the read-only regime, and now it starts to follow the existing master. So you can see that sometime later the stopped state changed to running state, and now it is working again. We can look into the Patroni logs to see what happened. Let's take the replica first. The replica didn't have any log. After that, at a certain point in time, the master stopped. It deleted the leader key, which is important, because in this case we will not have a case when we have two masters at the same time. Then the replica saw there was no leader key, promoted itself, and started as a master, and then continued working as a master. And the master saw that it received a request for switchover with these parameters, so it confirmed it was still a leader, but we have to specify the leader and switchover, because you can do switchover without stating the leader, and that's the leader will change. But then you don't do the switchover because this cluster status had already changed. The master was asking here, asking the replica for its status to make sure that we have a replica, that this replica can become a new master. So it made sure that the replica was working, that it was okay, and that it could become a master. And then it finally handed over the leader key. Manual failover demoting myself. Actually, it sent in two queries. Patroni API, Patroni control did the first query, and then the switchover happened inside the cycle of the high availability cycle. So Patroni made sure another time before it did demote that there was a replica and it was ready to start it. So it was a double protection, because if we do scheduled, if we do later switchover, then it does not make any sense to make sure that there's a replica that is ready to become a master. But then at night at 4 a.m. Before Patroni stops, it needs to make sure there's a replica that is ready to start doing this.
Here you can see that the master made a demode, after that it stopped, after that it started again. Here it checked whether it needs to do PG rewind. It decided that it did not need to do it because we did not record anything here, and it joined a new master and started replicating. It decided not to do PG rewind, not because nothing was recorded there, but because we had clean shutdown. Yes, we had clean shutdown, and it was not possible to record anything. What else can we do? I'm not going to show it to you. In lifetime mode, I will show you the slide. So the time that we wanted to do switch over is specified here. And instead of doing switch over right now, Patroni will include it into its schedule, and when this time, at this very moment, Patroni will do switch over. And it can show you that there is a switch over that is planned on this date for this node. So when this date comes, it will choose the replica and do switch over. Also, we have an opportunity to restart Postgres node. Why do we need it? You can restart this node using pgctl-d data directory restart. This way has one disadvantage. If this is a master node, it can lose master key during this time and do promote. I don't think that this is something that you wanted to have. The most frequent reason why you need to restart Postgres is either to change the parameters that are to be restarted, that require the restart, or to install a new minor version of Postgres 9.5.5 to 9.5.6, for example. So we can do it without losing the leader key, just saying restart. You can specify a specific node in restart and it will restart this node. Also, you can specify that it's necessary to restart all the nodes. Also, there is an opportunity to do scheduled restart. It's also very useful if you renewed your Postgres and you want these changes to be applied not during your peak load, but when there are almost no clients. It works similar to scheduled failover. You say that you want to do restart at this time, and after that Patroni does restart at this time and writes you that if you make Patroni CTL list, it will specify that cluster restart was planned. So this is what Patroni shows you. It is similar to Patroni's CTL failover. So until restart happens, it will tell you that it is waiting for restart, and it will tell you in how many seconds this restart will take place. And after it occurs, we will see that Patroni, that was master before, continues being the master, so it has not lost its lock. But if you decide to restart Postgres manually through PG control, Patroni will notice that, and it will not restart it next time. Who has read the article Postmortem in GitLab? Postmortem in GitLab. It happened a year ago. There is a link to that article. And this is a good read for you to understand what can go wrong in a big organization with problematic infrastructure. The idea was as follows. Their replica was slow, they decided to reinitiate it, PGS backup did not work up to the end due to some problems. They decided to delete data directory and deleted data directory on the master by mistake. It was it, game over. That's why we think that deleting replica's data directory is not a good way to reinitiate this replica because you can commit a mistake. Yes, it was done manually. That's why there is reneed command in control. It enables you to reinitiate the node that you specified. So we say reneed, name of cluster, name of node. It will request you to provide confirmation whether you really want to do it. After that, it reinitiates this node, and the status of Postgres will be creating replica. And after the replica it is created, the status will be ready. And if you say Patroni CTL reneed cluster and specified the name of cluster nodes reneed will not work. It will say that it's not possible to reinitiate master. If you really want to reinitiate Postgres on this node, you are to conduct switch over somewhere and after that reinitiate it as a replica, because we do not want to delete it in our master. This article is interesting. If they had Patroni, actually, they wouldn't have had to write it. There is also a pause mode. Why did we make it up? We have Patroni that manages Postgres cluster. It does automatic failover. And it starts nodes that were stopped before that. Sometimes we do not want to have it. Sometimes we do not want Patroni to conduct automatic failover because we're doing something with our Postgres cluster. We're conducting some manual operations and we do not want Patroni to meddle. We want Patroni not to interfere. And this is a pause mode. It is switched on by Patroni CTL, pause and number and name of the cluster, and this is a global mode for the whole cluster, so master and all the replicas will be transferred into this mode. It does not happen at once. They need to see the key of STD pause after some time, but it happens quite fast. Automatic failover will not take place, so if your master becomes unavailable, then cluster will continue working like that. It will not select some node as a new master, and it will not do promote for it. A useful function of this mode is that if etcd is not available, for example, if you switched it off for the purposes of upgrade or something else, then the cluster will continue working as is, but you need to switch on the pause mode before you do something with etcd. So at first you switch on the pause mode, and after that you switch off etcd, and your cluster does not start showing thousands of messages about errors. It continues working the way it worked until pause mode is there. So, in post mode, if you stop Patroni, and Patroni manages Postgres. So, normal situation, if you stop Patroni, Patroni stops Postgres. So, that you shouldn't stop Patroni and do promote of your replica. In that case, multi-master will be switched on. In post mode, Patroni will not do it. Postgres cluster will work the way it worked before. If you stop Postgres and Patroni is in pause mode, Patroni will not try to launch it. In a normal mode, Patroni will try to do it. It will think that something went wrong with Postgres and that it is to be amended. And in pause mode, you can stop Postgres, do something that you want to do with it, change binaries, for example, install extension or something else. And after that, you can launch Postgres. Patroni will not interfere. However, if the master and the replicas are working, the master will continue updating its leader key in etcd if etcd is available. Besides, in this mode, you will be able to create new replicas. So, if you connect a new node to the cluster, then in pause mode, this node will be initiated and it will get base backup from the master. And also in this mode, you can conduct manual failover. So if you say that you want this node to become a master, Patroni will consider it and change master role to the node that you specify. So switch over works, failover if the master dies will not work in this mode. The mode is like this. There is pause command. There is special key that will not return management to you until pause mode is switched on all the nodes. There is loop wait interval. After that, pause mode will be switched on. And in this mode, when you say list for cluster, when you say show all the nodes, it will also show you that pause mode is on. And in Patroni log, every node will notify, well, apart from I'm a leader and I'm a replica, it will say that pause mode is on. This is a mode for various operations with clusters that can change a lot for Patroni to notice that. And if you want Patroni not to do anything, you can switch on pause mode. In pause mode, what interesting thing can you do? You can promote one of the nodes that are replicas. So you have a cluster with masters and you have a replica in this cluster. You manually come to a replica, connect to it and say to replica PGCTL Postgres1 promote. And what do you have? Postgres Patroni does not interfere. It does not change the state of this cluster, so you have two masters in your cluster. This is not a multi-master, so they cannot communicate with each other, and you have a split brain situation here. What is interesting, Patroni will tell you that it is continuing working like a master, but it does not have a lock, so it does not have an identification in DCD that it is a master, because there is a leader key for another master, and I'm a master, but I work as a master without a lock. And this situation will continue up to the point when, another interesting feature. If you have this master without lock that was promoted by you and ask it through REST API, you will say, master, are you really a master? It will tell you 200. It's a normal master that has a leader lock. This fake master that was promoted by you in pause mode will say 503. Why? Because if you send clients to master, even if you promote one of the nodes manually anyway, clients will go to the real master if you use API for it. Fake master will not use REST API to say that it is a master. Anyway, it will continue saying 503. Maybe it will say 503 for the replica as well, so no one can come to it. What will happen when in this situation? So we have a split-brained master that does not have a log. When we switched off pause mode in cluster, the following will happen. This master that we created at once gets immediate shutdown, so Patroni will immediately say, we cannot be a master, we already have a master. Please do immediate shutdown Postgres. After that will be stopped. And when it is launched, Patroni will try do PG rewind for this third-party master to join the cluster. So PG rewind is launched and it managed to conduct rewind, and after that it was started as standby and secondary and it joined the cluster. So Patroni fixed this problem. What else do we have? Another useful feature when you want your clients to enter replicas, that is synchronous replication support. And synchronous replication support works in two modes. Actually, what you need to specify in Patroni configuration is synchronous replication mode. True or false parameter. This parameter will be applicable for the whole cluster. And what will happen? Patroni will find the replica that is good for synchronous replication, that does not lag behind, and add synchronous standby names parameter on the master. It will add this replica into synchronous state by names, so it will conduct a synchronous replication. But apart from it, Patroni will not do failover for any other replica apart from the synchronous one. If you said that you want a synchronous replica to constantly have data similar to the data of the master, Patroni will not let you do failover for any other replica apart from the synchronous one. What else is important here? Let's imagine that you do not have a synchronous replica. Somehow it disappeared, it failed, something happened to it. What will Patroni do in this case? In this case, Patroni will prefer availability to the opportunities of getting records from the client, and synchronous mode will be off, so you will have a master and synchronous replicas. However, the replicas that cannot be synchronous because they were marked as no synced, or you will have only the master, and in order to keep the opportunity of recording, Patroni will switch it into a normal mode, not a synchronous mode. And in some cases we do not want to have it, so we have a synchronous mode and we want to have two data copies. So if the synchronous replica disappears, then the rule that we have two identical data copies may not be observed. And in this case, if we really need to have synchronous replica, if this replica is not there, we do not accept records for masters, and Patroni can help you here. You can use synchronous stream mode. It is similar to normal synchronous mode, apart from one exception. If the synchronous replica disappears, then the master. So synchronous mode is there, and master stops accepting connection up to the moment when the synchronous replica appears again. However, you can switch off this mode for any query. Postgres has a very good function. For every specific transaction, you can specify whether you want to transmit it in a synchronous way or if you want to make it asynchronous. So even if you have an asynchronous replica, you can make transaction asynchronous. In that case, it will not wait until this transaction is transmitted to the replica. It can be done through synchronous commit parameters that can be set in a transaction. So you can make it local on the master. And in this case, it will not wait until this data is transmitted to the replica. And even if you have a strict synchronous mode, potentially you can lose this transaction if during this transaction everything fails. But it is your choice. Unfortunately, the speaker is off the mic. Unfortunately, no. Patroni can choose only one replica because The information about this replica should be recorded in etcd. And it's much more difficult when you have two replicas. In version 10, we have an opportunity to choose synchronous replicas by quorum. But in order to have two replicas instead of one, unfortunately, we cannot have it. So the question was whether we support more than one synchronous replica. No, we do not support it. We do not have a request. We have a discussion on GitHub. You can join the discussion, and together we can decide on the support of more than one synchronous replica. I want to show you how it can be turned on. I will repeat this command once again. So I added the cluster configuration, and after that, I say that synchronous mode should be switched on. So synchronous mode, true. Before that, yes. Before that, it was false by default. And I say that these changes should be applied. Let's check what happens in that case. We have the leader that has a log, we have a replica. And what is interesting here, as soon as these changes were applied, it found the replica. It is the only replica, it does not lag behind. So this replica became synchronous one, and Patroni shows that the parameters of synchronous standby name, so the parameter in Postgres that makes it possible for you to create replicas, was set in Postgres 1. And Patroni, Postgres says that Postgres 1 is the synchronous standby now. Nothing changed on the replica, but we can check Patroni's CTL list. And in this case, we will have a cluster leader, and this replica, its role will be synchronous standby, not just standby, but synchronous standby. So we can see that the cluster has synchronous replicas. And we also have a special endpoint that returns 200 only when you address the synchronous replica. So once again, 8009 sync. Okay, this endpoint returned 200 to us. Why do we need it? Your clients may need to read the data right after the data was changed. So you launched update, and after that you launched select on the same page, and you want this select to return the data that were updated. If this endpoint did not exist, you could get into another replica that has not received this data yet, because replication is asynchronous. In this case, we can use this endpoint in order to come to the synchronous replica and be sure that we get the most recent data. We also have a sync endpoint that returns 200 only if this replica is asynchronous. So in this case, we did a sync for the synchronous replica, asynchronous replica, and it said 503. Let's switch it off. We can say synchronous mode false. We can remove it from configuration, and in this case, some time will pass, and the master will switch off the synchronous mode. Here it is. It says that configuration reload was received, the synchronous mode was off, and if we have a list here, we will see that the replica is asynchronous. And if we address a sync endpoint, it will return 200. If we address sync endpoint, it will say 503. So we proved that the replica is asynchronous. Now Alexander will tell you about the ways you can extend Patroni's functions. Yes, I understand your question. So the question is, what happens if we want to restart asynchronous standby? Well, not exactly. So the question is, you have one master and one replica that is a synchronous replica. And we have two modes, synchronous mode and synchronous mode strict. Strict mode will prohibit any transactions on the master if we do not have a replica, and a normal synchronous mode, well, if we do not have a replica, it will switch off the synchronous mode and master will apply all transactions. This is the thing you need. And after you switch on the replica once again, the moment it catches up with the master, Patroni will make it synchronous automatically. Patroni enables us to do very interesting things. So we can customize various things, such as new replicas creation or new clusters creation. Or we can do some actions after we created a new cluster. Why do we need it? For example, we want to create new replicas without base backup, but with the use of Volley, because we have only one master. We have the backup that stays somewhere, it was made through Volley, and we want to create a new replica without loading the master. Patroni enables us to describe configuration and specify the scripts that are to be fulfilled by Patroni to initialize replica from some external source. So in this case, we describe replica creation method. This is the list. So Patroni will try to execute several methods from this list in the sequence of their description. So in the first list we have Volley, and for Volley we have its own configuration. This configuration includes command that is to be executed, and we can set some parameters. Parameters described in YML will be specially converted into the command line arguments. How does it happen? Well, some parameters have double purpose. For example, we have no master parameter. It means that this method of replica creation will be called and it will work even if there is no master. Why do we need it? Some unexpected situation may occur when cluster is not available, but you have backup and you want to restore everything from backup, so you should launch Patroni. Patroni will execute the command that will be taken by this backup, and new cluster will be deployed. We're speaking about physical backup, all segments and base backup. It is not pitch dump, it's not a logical backup. A logical backup is not actually a backup. It's a snapshot of data at a specific point in time. So how can it be converted into a command? We have Volley restore. Patroni starts building this command. It will give it the cluster name, data directory where our files should be stored. It will give it role. Actually, there is no sense in it. It will give it connection string. Using that, it can address the master. Why do we need it? You can address the master and understand how the situation changed and count how many headlocks were generated. If a terabyte of logs has been generated, then maybe recovery through this method is not the most efficient one. Maybe base backup is better. And it says no master and dir. This is a directory that contains some configuration parameters for Wally and, for example, retries. So the script is to process the majority of these parameters. So, if the return code was 0, so the command was executed successfully, we can try to start this cluster. If the command was not successful, Patroni will try the next command in the list. If there is no other command, it will not try anything, but during another iteration, it will try again. By default, when we create a new cluster, Patroni initiates it through initdb. But maybe you want to clone an existing cluster, so you have a cluster in production and you want to try changing it. You want to clone it the way it is. For this purpose, we support custom bootstrap method. It works similarly to custom replica creation method, so you describe the method and parameters for this method. So you need to write command. In this case, it is about scanning S3 cluster. In this example, we will do point-in-time recovery, so we know that an emergency happened here, some data were deleted, and we know when it happened. So, we describe the command that will take backup from S3 within this recovery target timeline, and after the backup was deployed from S3, Patroni will create recovery.conf with some parameters. So we specify that it's necessary to take the latest relevant timeline and promote at the moment when you reach this recovery target time. But promote should be done a millisecond before that. So a little bit before this target timeline. And after Patroni managed to do it, it will launch Postgres, and Postgres will start recovering Wally from some external storage from S3 in this case, and promote will take place. After that, Patroni will launch post bootstrap script. Why do we need it? In this script, you can create, for example, some users, some service tables. So these can be changed. You should know what you need. Initdb, well, it's the same. We can set some parameters for initdb. We can switch off trust authentication that is switched on by default for localhost. But it happens only after one of Patroni instances has taken initialization case, so this bootstrap will take place in one node. It's quite similar to the leader situation, but if one of the steps of this bootstrap is not successful, Patroni will delete initialize key and give other nodes a chance to try. If there are no other nodes, it will try it itself. Here you can see the example of post-bootstrap usage. We can create pgstrap statement extension inside template1 database. Why do we need it? Well, the user will create another database and it will have pgstat statements there. It's quite convenient because you cannot create extension. Normally only super users can do it, and you should not give super user rights to users. And now let's have a closer look at Patroni configuration file. Here we have several sections. First of all, we are to describe what cluster we have, and all the nodes that are related to these cluster scope should be similar. So here we use Batman namespace. This parameter says where we store information about our cluster inside etcd. By default, it's a service, but you can redefine it. You can use Patroni or something else, but this namespace should be similar among all the nodes of this cluster. We can also configure REST API Patroni on this specific node. So how Patroni will communicate with etcd, how we do bootstrap, what configuration parameters we want to apply to Postgres, watchdog, and tags.
REST API здесь, в общем-то, все просто. Мы говорим, на каком IP-порту мы будем слушать и каким образом другие ноды к нам могут обратиться.
You can switch on the SSL, you can put on the basic authentication. Since we support various DCIs such as console, you should also describe the host. You should describe what protocol to use. Maybe you need authorization, you need some authorizations or keys. This is all configurable. Zookeeper. The situation with the Zookeeper is more or less the same, and you don't need to authorize if memory serves. But for the Zookeeper, you'll need to list all the hosts in your cluster. Exhibitor simplifies this a bit, but people don't use it that often. We already have had a look at Bootstrap, discussed it. So everything described in Bootstrap will be used once when you're establishing the cluster. We already have a look at the Bootstrap method. Now, Postgres configuration. Two important aspects. You need identify listener address and connector address. That's the first one where you're going to listen. The second one is to address. It's for the replicas exclusively. And the second important aspect is the authentication. Patroni has to create a super user when the cluster is initialized, and the users for replication. And on the replicas, the parameters must be just the way they are on the master. And you can set up some configuration parameters for Postgres as well. We'll discuss this. Watchdog. If you're working on your hardware, then this is critical to set it up properly. There aren't so many handles which you can turn. There's a safety margins, for instance. For instance, it can ask you if 5 seconds before you exclude the leader key, you reboot the server to be on the safe side. And tags, this we discussed. You can use the environment, you can use other files, and basically you can take the entire configuration file and send via the environment variables. But importantly, no other environment variables will be used. Not even when you have sent the config in the command line. Okay, troubleshooting. This is if something happens, this is not accessible, then this node starts returning errors. it will show you a message that this is not until it is not available again. The most frequent problem: you install Debian, you have binary files, Postgres PGCTL, and all the other files are somewhere not in the path variable, but somewhere else. Then you launch Patroni. Patroni crashes and it returns this error. Subprocess call says no such file pgcd. There cannot be any master after that because Postgres binaries are not available. The solution is quite saleable, quite easy. You go to the file configuration, you specify then there, or alternatively you specify the path binary files. I showed you this error already. When Patroni creates replication slots for Replica, it takes some time. When it sees the replica is there, then it shows you for about 10 seconds that you cannot send the start replica because there's no slot. initdb, you can specify initdb inside Patroni. In some cases, people stated the configuration incorrectly, but for instance, we have the checksum parameter, which allows to include checksums. So this initdb parameter is shown as minus data checksums, minus checksums. The Patroni wants it to see the same way. If you specify data checksum true, you'll see this error message. So initdb will not work in this case. You'll have to change the Patroni configuration. And my favorite error. YAML is the format which is not available, which is easy enough and simple people can use it. But formatting in YAML does have a certain meaning. If you forget to make a space, put in a space, then YAML will think these parameters are the same level. In this case, what it's trying to do, it thought that was a line. It tried transforming it into a line. So if you see something similar, then you should validate your YAML. We should actually validate your YAML always before you do this. And last but not least, you install Postgres on Debian or on Ubuntu. It does initdb by default for the cluster, and maybe even launches it. What happens if after that, after initdb, you try connecting this node to a replica? There's a master, there's initdb. Each Postgres cluster has this system identifier, which is similar in all the nodes, on all the masters, all the replicas, and on other clusters, which is made using initdb. So when you attempt to connect such a cluster, the system will return critical error. The system identifier of the existing cluster does not match the system identifier of the replica you were trying to connect to. So the replica will not be able to connect. I cannot continue. This is done on purpose so that you don't lose any data. When you connect to a node which has nothing to do with this cluster, and so that the system doesn't do a re-init after you do so. So the solution, if it's on Debian, if you have a data directory, the solution is to delete the data directory. Basically, that is it from our tutorial. There are some useful links in Patroni. It's on GitHub. You can go there, you can open an issue, go there or make a clone and launch it. There's documentation about Patroni. It's on a separate address. Patroni the docs.io. This documentation supports search. It has a detailed description of all the parameters of how Patroni works and various regimes, replication, etc., or how other parameters work. There's a Docker image, which includes Postgres, Patroni, a lot of other things. It's also on GitHub, in open source, and we use it at Zalando, so you can also use it. Thank you very much. Thank you. Thank you for coming here. I'm very sorry for these inconveniences. Please come to our next tutorial. And now we're going to take your questions.
Вопрос был еще раз.
So the question was about Kubernetes. In Kubernetes, we launch Patroni in Spilo, and we manage it through Postgres operator. It's a separate open source project. Yesterday, I made a presentation about it. The slides will be published on the internet. That's a good question. We hope yes, because Red Hat is interested in it as well. Namely, George Burgess is interested in it. OpenShift support presupposes the presence of OpenShift. That's why people who are interested in it are engaged in its support. I think that it will be there. Other questions? Yes, we understand your question. You already have a master, you have an existing standby. So, can you link Patroni with the existing standby without reinitiating? Am I right? Yes, it is possible. First of all, you are to launch Patroni on the master so that nothing unexpected comes up. And after that, you should launch it on the host where standby is operating. But this operation is not well documented. And before doing it on production, you should better train somewhere on your laptop, for example. But actually, we have done it. We have such a situation. In a typical data center, we have a master and a standby. At first, we launched Patroni on the host where the master is. It recorded everything in Zookeeper in our case. After that, we launched Patroni on the Replica. So Patroni understood that we have a master already. And this cluster started operating under the management of Patroni. C3 is data store available service. For this purpose, you can use not Volley, but something else. All of it can be customized. You can write any scripts that will execute backups. And if your question was whether it's possible to use S3 not from Amazon but from a local machine, well, yes, you can do it as well. You can back up on S3 even without being in Amazon, if you need it. Yes, I remember that you had a question. So if you launched Postgres through a special command, Patroni manages Postgres on this specific node. So for every node, Patroni launches Postgres. You cannot make Patroni launch several Postgres, one Patroni on several nodes. So the question is whether line is customized, Postgres line is customized in Patroni. No, it cannot be customized. Why do you need it? I did not hear you, sorry. Well, you can specify it in Patroni parameters. You can specify in Patroni YML where your unit socket directory is shown, or you can change port of the host. Oh, you mean core processing units? I think that you will need to launch Patroni on these CPUs, because Patroni will launch Postgres. It is inherited. Actually, I don't know. I think so, because you launch Postmaster, that launches Postgres after that. And if it works for Postgres, that is about a lot of processes that are launched by Postmaster, then it will work with Patroni as well. But in your case, I would experiment, so you can apply these parameters in Patroni. Yeah, it sounds logical. Do you have other questions? Yes? Well, it will happen. If something happened to synchronous replica, then from existing asynchronous replica that meets some criteria, Patroni will change the next synchronous replica. So when it does not have a synchronous replica, it can go into asynchronous mode, or it can work in asynchronous mode, and it will not accept connection until it has a replica. But we should remember that all these operations cannot happen at once. So it will take some time to understand that the synchronous replica failed. Do you have other questions? Yes, please. Last question. Unfortunately, the speaker is off the mic.
So the question is it possible to use Patroni on physical servers instead of Docker, instead of cloud? Yeah, absolutely. Patroni is not tied to any container. So you can just run Patroni on a local server. And this is what we actually did here. So we had a virtual machine, and we ran Patroni inside the virtual machine, and it worked marvelously. We actually use it on physical servers inside Zalando. So it's not tied to containers. There is a Spilo that is a Docker image that is basically a Docker container. But Spilo has Postgres and Patroni, but Patroni itself is just a Python daemon that can work anywhere. Yeah?
HA proxy, it's a load balancer, and primary goal of HA proxy, it's forwarding traffic from clients to the master. Because if you have more than one node in the cluster, let's say 3 nodes, like it's a responsibility of HA proxy to figure out where the master runs. And when client connects to HA proxy magically or automatically will forward it to the right node. Basically it's a queries and response, Postgres queries. No, it's a general proxy. In this case, it acts as a usual TCP proxy. It does not speak Postgres protocol, but it just forwards all TCP traffic from client to the Postgres.
We can answer other questions, but I think that it's time for us to leave this room in order not to take additional time. Thank you for your attention once again. It was great.